All right. Hi, Simona. I guess.
Hi, everyone.
Hi, everyone. So, hi, everyone. Welcome back to the Leipzig Lectures on Language 2021, end of the year symposium. We are, sadly enough, at the end of our two-day symposium. We went through two poster sessions for workshops. Personal opinion, 4 fantastic workshops, very quite a great keynote lectures from William Mancini. Very happy that he's back again. We hopefully made the frame of insisting on how good it is to have theories for making hypotheses about the brain and hypotheses about how language might be reflected in brain components. As you can see, we will end up this two-day symposium with Simona Mancini from the Linguistic and Efficiency Group in San Sebastian. Before introducing her, I would like to give you a couple of info regarding participation guidelines, as usual. So please keep your microphone muted. You can post your questions into the YouTube chat. Don't forget that we are now live also on our YouTube personal channel, and you can preface your questions by using the Q, or if you're a junior researcher, please type down QJ before asking a question, and junior researchers have priority. You can also post questions on Twitter using the hashtag Leipzig21. Before introducing Simona, it's also important for me to inform you that we have live captioning that you can activate at the bottom by clicking on live captioning. Right, we can move to Simona's work. It's an absolute privilege for me to introduce Simona, an old friend of mine, back to the Siena times when we were both interested in linguistics. Simona in a more advanced fashion than me, for sure. Simona is a Hamoni Kayal Fellow and leader of the Neuro-Linguistics and Efficiency Group in San Sebastian. She obtained her PhD in cognitive science from the University of Siena in Italy. And her scientific activity lies at the intersection between theoretical linguistics and cognitive neuroscience. That's something that we really appreciate, focusing on core computational mechanisms and their processing correlates in adult speakers, but also second language and language impaired speakers using both behavioral and neuroimaging techniques. Simona has a network of quite active collaborations, including European, North American, Canadian universities. The title of our talk today is Feature Combinatorics, which I think is already quite telling. Simona, the stage is yours. Generally, we agreed on 45 minutes, 50 minutes, and then hopefully we'll have a nice, some nice chat afterwards on the presentation of the data. So thank you very much, Simona, please.
Thank you, Emiliano, for this really kind introduction, and above all for giving me the, well, can you see the screen? No, I guess you can. No.
Now we see PDF, don't worry.
Yeah, now you see Osteoten Mobile. Yes.
This is meant for Android effects, exactly.
Okay, I thought, let me move the, can you see? No, you can't see it now. Oh, gosh.
All good.
Okay, I guess you can see it now.
Okay, you're in the...
Yes, no. Okay, can you see it now? Okay.
Yes, so, perfect.
Okay, let's rewind. As I said, thank you very much for your kind introduction, Emiliano. And I have to say that I'm not only honored, but I think it's a privilege to be invited to take part in this series of events. And I really enjoyed several of the talks that the tandem talks that I attended, and yesterday's talk by William. So I hope today, I mean, it will be as enjoyable as it was before. So what I'm going to talk about today is somehow follows what William was talking about yesterday about morphology and agreement. So during comprehension, we not only build a basic syntactic structure, but we also effortlessly extract and detect an intricate net of relations among lexical items, among words. So we're aware that in a sentence like the cakes that our brother bakes are very tasty, are and cakes form a relation because they both are plural. And while this may seem quite an articulate net of relations, so it is nothing compared to what we would find in Spanish. And so borrowing, so using a metaphor from soccer, we could say that here Spanish wins English 10-5. And as a proud Italian, I could say that the same would do Italian. So these nets that connect words are called agreement relations. So cakes and are here are said to agree, and they agree in person and number information. So, but there's also gender information that is shared between, for example, his and brother. So what these are usually, well, these are usually called in linguistics and theoretical linguistics agreement, and the information that is shared is agreement features, basically. So, and we'll talk about mostly person and number, and of course, from the perspective of Spanish. So the goal of this talk is to give you a snapshot of how we go from features, from the extraction of the featural information that we find in the linguistic input, to establishing a relation and interpret them during online comprehension. And on a more theoretical level, I also aim at answering the question of whether features and the operations that the online process, the online parser does on features can be regarded as relevant linguistic representations and relevant in fundamental processing routines in the sense of the representational and algorithmic levels that are described in Mars tripartite model, for example. So anticipating the answer, I think this is still to be seen, but it's something that we'll discuss during the question time and during the discussion time. So, and eventually, I hope that this can lead to a reflection on how the relation between the linguistic theory and neurolinguistics, and on how these two disciplines can and should talk to each other. So, more concretely, I'll briefly go through some theoretical background on agreement and agreement features, and then I'll focus on how relations are established during online processing. And I'll touch on decomposition and maintenance mechanisms, but it will be a very brief interlude because I'll focus mostly on integration of subject-verb agreement specifically. And I'll provide evidence from event-related potential, side tracking, and FMRI data in the visual modality. And I'll conclude and then giving some current and future directions, but also open issues. Okay, so what is a feature? So borrowing a term from physics, Sigurdsson defines features as language quarks, so as atomic elements. And why atomic elements? Because features are the minimum level of linguistic analysis at which we can map form onto meaning when it comes to syntax, for example. And thus, it's the minimum level that can help us derive the overarching meaning of an agreement relation, but ultimately of a sentence. They contribute to understanding who does what in a sentence. So, leaving the world of physics and entering the one of language, the function of features is to capture regularities within and across language components. So in a word, we can features as transmodular elements. So phonological systems can be described in featural terms, but also parts of speech can be captured with, for example, a plus-minus noun or plus-minus verb feature. And semantically, features can be also used to describe the state, animate or not. In morphological terms, for example, person, number, and gender features refer to the different inflection, the different form or morphology that a noun or a verb can appear in. So, for example, in English, the noun house can take the form houses when it is plural. So the S signals the plural feature. And when this morphological form is triggered by the presence of a noun or a verb with which an agreement relation is formed, these features become interface features. They are morphosyntactic features that operate at the interface between these two levels of analysis. And so person and number in subject-verb agreement, for example, have this function, are morphosyntactic features. And we will focus on this type of features today. So the last aspect of features that I would like to emphasize in this introduction is the fact that they are common currency in linguistics. So they are a place where different theoretical frameworks can converge. Although the function and representation that each of these frameworks attribute to these elements can be quite different. So, for example, in generative grammar accounts, like the minimalism and cartography, to which I make reference, features are the probes and goals of syntactic computation, but this is not what happens in other frameworks. But what I want to stress is that regardless of the inspiration or regardless of what the main engine of the architecture of language is in framework, always space for feature descriptions. So how do we go from features to relations? Now, agreement does not occur in a vacuum. So before a subject and a verb, or element A in general and element B can be integrated, there are some preliminary steps that are necessary. And these include the identification of meaningful linguistic units. And the mechanism that should carry out such function is the composition, basically. And we know that the composition routines operate early and automatically, and that they are operative at about 170 milliseconds after stimulus presentation, when some recent models localize temporally the composition of the written input into morphemes. So in her model, Laura Williams identifies these mechanisms, localizes these mechanisms to the anterior fusiform gyrus, so in occipital areas. Interestingly, in an MEG study in Spanish, my colleague Nicola Molinaro showed that the detection of a number anomaly between a determiner and a noun generates increased activity in occipital regions at about 180 milliseconds post-stimulus onset. And they associated this effect to morphological decomposition routines. So this clearly shows that sensitivity to morphosyntactic features emerges early during the processing of written input. Now, what does the parser do with elements A information? So it very likely maintains it for subsequent use, that is for when element B will come in and the information can be integrated. So this is a question that Bojana Ristic, a former PhD student in my group, addressed in her thesis, and so in two eye tracking during comprehension experiments, she manipulated so she measured the fixation time, the reading times during the reading of an embedded clause that was interpolated between a metric subject that was looking for, so to say, the verb with which it would and she reasoned that if information that is extracted from the metric subject is maintained active during the reading of the embedded clause, so in this experimental embedded clause, we would see an increase in reading times compared to experimental embedded clause that is interpolated between an adjunct clause that contains the same NP as the control condition, but the NP doesn't have any grammatical function. So it's not looking for a verb with which to agree. And then a metrics clause that has its own, so to say, independence. So it appears that an increase in reading times, both in English and in Spanish, through the experimental embedded clause. compared to the control one. So we could conclude that there was active maintenance of the subject's information during the reading of, while the dependency was being created and established. Now, when B comes in, we decompose it and extract a number and person information from it. And in order to integrate these pieces of information with A's feature array, we need to check their consistency. Now, but for person and number information to be interpreted, we also need to anchor their morphosyntactic value, so first or second person or singular or plural number, to their interpretive correlates, or so which, for example, for person are discourse roles, like the speaker for first person or the addressee for second person. But we'll go back to this in later on during the talk. But so what I want to stress on is the fact that establishing an agreement relation bears not only syntactic but also semantic and discourse correlates consequences. So, and because these anchoring values are intrinsically different, so it is plausible to ask whether the processing system discriminates among them during the interpretation of an agreement relation. And another plausible question that we can ask is whether we can functionally dissociate feature checking from feature mapping during integration. So these are the two questions that we have tried to address in the work that I'll be showing, and that we'll try to also to answer today. So what do we know about the integration of agreement information during online processing? The most common design that is used to test agreement is the so-called violation paradigm. So where you have an agreement anomalous element, like the verb here, the linguist tolerate, as opposed to an agreement correct verb, the linguist tolerates. So they're compared, and psycholinguistic studies have shown that the detection of an anomalous agreement relation reliably generates increases in reading times. And when you measure these reading times in an eye tracking experiment, you see that the fixation time in the anomalous region, the first pass through the anomalous region increases. So the reading time through the first pass in the anomalous region increases. It gives also rise to increased reading times in the spillover region, so the word next to the anomalous one, and sometimes also regressive saccades, so a second pass through the anomalous region, which overall increase the total time spent reading this anomalous condition compared to the correct verb. Now, there are also ERP studies, several ERP studies that have been conducted, and they have shown that across languages, the detection of an agreement anomaly generates a biphasic pattern with a neuronegative effect, usually associated with a mismatch detection, but so between 300 and 500 milliseconds. But across languages, this effect is not stable, either in its presence, both in its presence or absence, and also in the distribution in the topographical distribution of the effect. So we find left anterior negative effects that are classically associated with a morphosyntactic mismatch detection, but also early negative effects with a more central parietal distribution, M400 effects are classically, let's say, interpreted as evidence for some sort of lexicosemantic processing going on. But when it is there, the early negative effect, it is followed by a late positive effect, like the one you see here, that is classically thought to reflect is triggered by the detection of a significant of a conflict. Now, recently, neuro studies have also shown that detecting an agreement anomaly triggers increased activation profiles in a number of frontal and temporal areas. And we will see this more in detail in a second. Now, where can we find evidence for a dissociation among features in these patterns of effects? And can we find evidence for a dissociation between checking and feature mapping mechanisms within these patterns of effects? So Okay, so before delving into experimental findings, let me first clarify what I mean with checking and what I mean with mapping and what we can expect. Now, with feature checking, I refer to a mechanism that incrementally checks the fit between the expected and the perceived element. And for this mechanism to work, we need support from a working memory system and also from top-down predictive mechanisms. So neuroanatomically, plausible candidates for supporting this kind of mechanisms are the frontal cortex in tandem with the posterior portion of the temporal lobe, whose collaboration in assembling syntactic structure is well known, although it is debated whether basic hierarchical structuring is supported by the left IFG or the posterior midtemporal gyrus. But anyways, this could be two neuroanatomical candidates. And electrophysiologically, we can expect a modulation of the early negative effects. With mapping, I refer to a mechanism through which the representation underlying features is accessed, and this is where dissociation among features can occur. So at the level of feature mapping. And the neuro-anatomical candidate that could support these mechanisms can be localized in the temporal cortex, and in particular, I think in the anterior part. So indeed, during sentence processing, this region has been found to play a fundamental role in semantic combinatorial mechanisms. And evidences for this, for example, has been provided by Payet et al.'s study that showed that when comparing Jabberwocky with normal prose stimuli of increased constituent size, this region is specifically responsive to the presence of lexical semantic information. So, but there's also evidence from semantic dementia patients that this region has a sort of a semantic hub. Okay, so we'll start with feature dissociation. In the next three studies that I'm going to show you, we'll compare a person violation, so an anomalous sentence in Spanish, where a third-person singular subject is followed by a second-person singular verb. So the number is kept constant, but what changes is person marking. A number violation, where the person marking is kept constant, third person, but the number is manipulated. So we have a singular subject followed by a plural verb. And of course, a correct agreement condition. So what we should keep in mind is that when violating person agreement, the effect of a person anomaly is on the assignment of a discourse role. So on who does the speaking or who does the listening, for example. While violating a number has consequences for determining the cardinality of an entity. So whether there's one or many of that identity. So, and we'll start with eye tracking and follow with ERPs and FMRI. So in this eye tracking experiment, Nicoletta Biondo manipulated, of course, person and number congruence within subject-verb agreement. And overall, what she found was that there was an increased reading time for the two anomalies during the first pass through the region, but it was in the total time that this dissociation between person and number emerged, with person mismatches giving rise to a greater, longer reading times compared to a number mismatch. So this is a person and this is number. So the interpretation we gave to this difference was quite a linguistic one. So, and it's one that makes reference to the differences in the underlying representation of person and number agreement. So, recall that what I said about the different anchor points for person and number. So, for person, the interpretive anchor point is in what generative linguistics, generative syntax identifies in the left periphery of the sentence. So in that part of the sentence structure that encodes information about discourse, for example, the time and location, but also the speech participants, the participants of an event. So when person agreement does not only involve the inflectional layer of sentence structure, what is usually called the IP or TP, but there's also a link to the left periphery of the sentence, which does not occur for number, which is more locally, so to say, interpreted. So we attributed this difference between the two violations to the different disruption that to the greater disruption that violating person has compared to number, because person implies more articulate syntactic structure and more, let's say, a wider spread consequences. Turning to ERPs, both violations generated an early negative effect, as you can see, followed by a late positive effect. And the negativity elicited by number anomalies had its maximum in left anterior sides, while the negativity elicited by person mismatch was more broadly distributed, and its maximum was central posterior. So when compared, they were found to differ posteriorly, but not anteriorly. So we interpreted this broad negativity for person anomaly as a superimposition of Blanc and pharyngeal defects. And turning to FMRI data, the contrast between the correct agreement condition and the two incorrect conditions collapsed, here indicated in purple, indicated that increased patterns of activation in left inferior frontal gyrus areas, but also in temporal areas, both middle temporal gyrus areas, both anterior and posterior. The contrast between the two, between each violation, person violation and number violation compared to control, showed middle frontal and bilateral parietal activation, as you can see here. So the yellow indicates the common activation between the two violations. And finally, the red contrast between person and number show that both violations here in yellow generated increased activation in the posterior middle temporal gyrus, but there was a quantitative difference between these two mismatches, with person mismatches eliciting greater activation compared to number. Now, this quantitative difference, this dissociation becomes even more evident as we go anteriorly. So in the anterior portion of the middle temporal gyrus, where there's activation for person violations, but not for number violations. And the same pattern can be found in the pars orbitalis and triangularis of the inferior frontal gyrus. So what can we conclude from these three studies? So we saw quantitative differences between person and number during reading. We saw similar anterior negativities, but different posterior negativities for the two violations in ERPs. And we found similar middle frontal activation, but different temporal and inferior frontal gyrus activation in fMRI data. So it is tempting to conclude that these two mechanisms, these two violations rely or the processing of these two types of agreement relies on similar mismatch detection, but different mapping mechanisms. Now, as tempting as this may be, there's a caveat here, I think. And so violation paradigms are very convenient in that they show the kind of reaction that the processing system has when it is forced to deal with a certain type of information. So here, person and number information. But this doesn't come short of consequences. And the most evident of these consequences is the fact that whenever an ungrammatical sentence is generated, there's also a failure to interpret the sentence that follows. So, and this can blur the boundary between terms that one may want to dissociate, like feature checking and mapping in our case. So what we want is a means to that allows us to observe feature checking that is not contaminated by ungrammaticality, and that can lead us to successful mapping and so to successful interpretation without the inconvenience of ungrammaticality. So it turns out Spanish can help us solve this conundrum. So now we'll first see some theory behind it. So, and I'll zoom into person agreement, and we'll see and into the asymmetries between the participant roles that this feature entails. So the asymmetries between its anchor values. So the individuals engaged in a speech act can be assigned 3 different roles, depending on whether they are first, second, or third person. So the first person refers to the speaker. So the person who does the speaking. The second person refers to the addressee, you, who does the listening usually. And third person refers to a non-participant, so someone whom the speaker and addressee talk about. So in our example here, the linguist. So in the person mismatch, like the one we tested in our previous study, we were basically attempting to assign 2 incompatible roles to the same individual. And this, as we saw, generated sizable interpretive difficulties. So is it the same with plural persons? Not exactly. So first person plural can be understood as a combination of speaker and associates. So I is first person, so we is I plus you, or I plus she or they. Second person plural, you is you plus you's associates, so it could be she or they. And so in both cases, we have multiple entities with participants and non-participant roles. And this composite representation contrasts with the homogeneity of third person plural representations, which consist of a group of individuals with non-participant roles, so a homogeneous group of linguists. Now, suppose we combine a third-person plural subject and a first-person plural verb, as in los lingüistas toleramos errores de concordancia in Spanish. So we have, so the underlying representation of the subject, of the third-person plural subject, entails a homogeneous group of non-participants, linguists, while the verb implies a composite group of participants and non-participants. So the question is whether we can integrate these 2 representations to derive an overall will linguist interpretation. So something along the lines of what happens in British English with the committee are type of sentences, where are, plural are, the plurality of individuals that a committee entails. So the answer is yes. This pattern is attested in standard Spanish. It's called an agreement, so something that is neither agreement nor disagreement. And it's also attested in some other Romance languages. So when asked to evaluate the acceptability of sentences like an agreement, native speakers of Spanish have no doubt about their acceptability. And this occurs both in time pressured and time not pressured paradigms. Like so, here you can see in this bar plot that when asked to, when participants are asked to provide an acceptability judgment, so they're quite as positive about the acceptability of an agreement as when they are evaluating an agreement, a default agreement. I'm sorry. Okay. So in the following 2 studies that I'll present, we contrast person violations of the type we saw before. So third person singular subject followed by second person singular verb, which leads to an outright violation, as we saw, and an agreement patterns where third person plural subject is followed by a first person plural verb, which is not, and which is acceptable. And we'll come to default agreement sentences, so where subject and verb agree in both person and number, both apparently, and they are consistent. Okay, so and we'll go through ERPs and FMRI data. We have also the eye tracking data, but in the interest of time, I haven't included it. So. Okay, so person violations replicated the same biphasic effect seen in the previous ERP study. But the unagreement condition compared to a default agreement showed an early negative effect between 300 and 500 milliseconds, like person violations, although the intensity, the amplitude of the effect was, of course, lesser, but no late positive effect. So in both cases, both person mismatch and an agreement manipulate. So in both cases, we manipulate person. So this may be this may be what triggers the fact that in both cases, the amplitude of the effect is different. As I said, the maximum of the effect is both left and central parietal. So we can positively associate this 300 and 500 millisecond interval to a mismatch detection mechanism, so to say. Okay, so moving to FMRI data, and this is work by Ileana Quiñones. So we adopted the exact same design in an event-related FMRI study, and this study allowed us to disentangle those regions that are responsive to the processing of interpretable agreement, both when it contains a featural mismatch and when it doesn't, and from instances of agreement that contain a featural mismatch, regardless of their grammaticality. So in the first case, so both an agreement versus person mismatch and default agreement versus person mismatch elicited a greater elicited significant activation patterns in the left inferior frontal regions and middle temporal regions, both on posterior and anterior. So as you can see here. And turning to the unagreement versus default agreement, we see activation in middle frontal gyrus, exactly as for person mismatch. But the unagreement versus default agreement also shows activation, significant activation in the angular gyrus, while the person mismatch shows bilateral parietal activation. So here you can see how the two mismatching condition, regardless of their grammaticality, overlap here in middle frontal gyrus. Yeah. Okay. Let's wrap up and see if we can unpack integration mechanisms, which sounds like an oxymoron. So the left middle frontal gyrus responded consistently to the presence of a mismatch, regardless of whether it was grammatical, as in an agreement, or not, as in true person violations. And in contrast, the IFG and the left IFG and the middle temporal gyrus were more responsive to the presence of interpretable agreements, so an agreement and correct and default agreement. Okay, so let's go to the conclusions and let's see how these results fit within a bigger picture. So I focused on person and number within subject-verb agreement, but the range of features that we have tested in fMRI includes as well determiner noun agreement, so for example, gender and number agreement within determiner and noun. So the picture is bigger, and I want to show you the bigger picture. So here in the three figures on the right, you see, so these are derived from the superimposition of the 5 experiments, the superimposition of the activation profiles across the different experiments. So what we found was that the left middle frontal gyrus selectively responded to the presence of featural mismatch, while the inferior frontal gyrus was equally sensitive to a feature match and feature mismatch. And finally, the left middle temporal gyrus was more responsive to feature match than mismatch. So, evidence for feature dissociation is found both in the IFG and in the middle temporal gyrus. Here, I'm referring to person and number because this is these are the cases that we have discussed so far, and I don't want to add too much stuff on the plate. So I'm happy to talk about gender in the question time. So what can this tell us about the mechanisms that are supported by these regions? How can we combine all these findings? So let's do a step back and recall the linguistic interpretation that I gave to the eye tracking data for person versus number violations, whereby we established that we interpreted those findings in terms of the more articulate syntactic structure that person agreement projects compared to number agreements. So this could be behind the quantitative difference that we find in the posterior midtemporal gyrus between person and number. So it could be that one interpretation of these findings is that the posterior midtemporal gyrus observes mechanisms that are associated with the extraction of hierarchical information from not extraction of hierarchical information, hierarchical syntactic structure, which in this particular case is sensitive to the to where morphological information can be found. And checking the fit between assuming the hierarchical structure of the input is incrementally built in the posterior midtemporal gyrus, then this flow of information and the fit of the elements that are built can be constantly evaluated in frontal areas. So recall that we said that checking the fit between incoming and previously analyzed items requires support from working memory mechanisms and top-down predictive processes that the frontal cortex can provide. And also, interestingly, this region has also been indicated as one of the potential neural generators of left anterior negative effects, so together with temporal region. So this could provide further support for our hypothesis that the frontal cortex observes this fit evaluation or checking function. So the more anteriorly we go, the more the midtemporal gyrus appears to be selectively responsive for person and not for number. So previous studies have associated this area, as I said, to lexicosemantic combinatorial mechanisms, and certainly the identification of the discourse role invoked by the subject of an agreement dependency, so whether it refers to the speaker or the addressee, so could be of high relevance to derive the overarching meaning of the sentence, so or at least of higher relevance compared to number. And this could explain why person violations activate the anterior midtemporal gyrus, but number violations don't, or not to a significant extent. Importantly, this area has also been identified as a potential neurogenerator of M400 effects, as suggested by Lau and colleagues. So, crucially, the dissociation that we found in the anterior temporal lobe reflects the one we encountered in the pars triangularis and orbitalis of the IFG. So there are some studies on semantic combinatorics, like the one by Molinaro and Paz-Alonso, 2015, I think, that have shown that there's a tight functional connection between the anterior temporal lobe and the pars triangularis and orbitalis during semantic combinatorial processing. So these two IFG regions could be specifically involved in checking the semantic discourse fit between the perceived and expected input. So we can sum up our findings by saying that processing agreement relations or integrating agreement relations is feature sensitive, is not a monolithic process, and I hope I have provided converging evidence from converging and convincing evidence from different techniques. So I would like to now close this talk by illustrating some current directions and open issues, not only in the study of agreement. So, and I want to go back first to the dissociation that we found between the IFG and the midfrontal gyrus. So in their 2012 paper, Fiorenko and colleagues proposed that domain general and domain specific mechanisms lie side by the frontal cortex. So if this is so, then a plausible interpretation of this dissociation that we found in this area, so with the left middle frontal gyrus being more sensitive to, being specifically sensitive actually to featural mismatch, and the left infrafrontal gyrus to both match and mismatch, it could reflect the interplay between domain general and language specific mechanisms, the former being, so the domain general being supported by the left middle frontal gyrus, and the language specific mechanisms being more localizable to the left infrafrontal gyrus. And this question connects to the assumption that not all language operations are domain specific, which is something that embraced in more recent formulations of, for example, the minimalist program. So it connects to also findings from the cross-domain processing of this that have shown that the establishment of relations between symbols based on color and size, for example, in a symbol-based syntax, engages frontal areas that partially, not completely, but only partially overlap with areas recruited for the processing of human-like artificial languages, as evidenced by Titamanti and colleagues. So this is, of course, an empirical question, and I'm not saying that agreement is fully domain general, but I'm just a question that so a reflection that I've made is whether maybe, what about its underlying checking mechanisms? Could this be a model? This is actually a work in progress. We're working on a study to test agreement in a visual spatial domain, and we're also working on a study to test to what extent the computation of agreement is resistant or resilient to interference that could disrupt the awareness with which we detect this relation. So there's prior evidence by Batterink and Neville that shows that basic syntactic structure building occurs outside of conscious awareness, but it's unclear so far whether this is generalizable to other early computations such as agreement. We're also investigating impaired agreement, so in recovery after stroke. So this is our recent research line that we have started in my group, the neuro-anaphasia group. So we're testing a recovery from acute to chronic, and also its interaction with domain general mechanisms. This is work that is being carried out by my PhD students, Karen Arellano and Xavier Serena, and together with Miguel Ángel Santo in Barcelona. We're also testing it in primary progressive aphasia. So one important question of the work that I presented so far is how generalizable are these findings and claims that to inflectionally poor languages, because I've talked about Spanish, and Spanish has very rich inflectional system, a rich feature array. But what happens in inflectionally poor languages? So we know that languages differ in their repertoire of features and their degree of inflectional richness. So linguistic theory has it that when agreement features like those we have been talking about, person, number, are not available, as in Japanese or Chinese, there are other features that can take over and aid the parser in establishing relations among lexical items. So this could be something to test. And also, importantly, I stressed a lot on the evidence provided by early negative effects to claim the presence of checking mechanisms. But so a legitimate question here is whether this mechanism is operative in inflectionally poor languages as much as it is in Spanish or in Basque. And the variability of left anterior negative effects across languages would suggest that it isn't. But I think this is the short answer. It requires deeper analysis. So it is a fact that early negative effects and their presence and distribution are variable, and I'm not factoring in potential methodological differences here. But so the long answer to this could be that yes, they're variable, and they don't consistently arise, but this probably has to do with the weight that morphosyntactic cues have in a given language and how relevant they are for the assignment of interpretively relevant roles. So I'm not the first one to say this, but so when they are not relevant for the assignment of interpretively relevant roles, there are other cues that can take over, like positional or word order cues, and these reliably elicit early negative effects. So even if the parser deals with word category information, which is also a feature, and it checks its compatibility with the preceding elements, it's still doing something that is computationally and algorithmically alike to what it does when it checks the consistency between agreement features. So anyway, at any rate, we need more evidence from other languages that are not Spanish, English, or so I'm doing my part with Basque, but we need more evidence with non-European languages. So, and finally, this is the very last slide. I want to conclude with a question that is directly connected to the cross-linguistic implications that I've just pointed out. So, theoretically, features are quarks. We talked about that. They're transmodular and they're potentially theory neutral. So, and they have proved useful to decompose the combinatorial operations that underlie agreement processing. But what do we consider a relevant feature? So I've talked about person and number, but again, languages differ in their repertoire of features. And more importantly, how do we constrain the number of features that are relevant, as Evelina Leivada correctly pointed out? I think these are questions at the interface between a theoretical and the experimental study of language. And I know I should be taking questions and not asking them, but with this, I thank you very much for your attention. I thank all this bunch of people here who have collaborated, inspired, and supported the work I've shown, and also the funding bodies here that have supported financially this work. And I'm happy to take any question. Thank you.
Thank you very much, Simona, for the great talk. Very timely, precise. Thank you very much. So we have time for a few questions. So anyone who would like to pose questions, please type down in the chat. You can prefix it with a Q or with a QJ if you're a junior researcher, and junior researchers have priority. So in the meantime, Simona, maybe we can begin. Maybe I would like to ask,
sure,
just to start with a general question about probably the model that you're proposing. So I guess slide 30, but we don't need to go there. So where you begin to allocate different roles to the different regions, and I'm wondering whether we can frame it in a better way, so that the checking of an agreement feature in the IFG, it's something that interests me particularly to understand better. And if we can give also a more processing definition, if it's really a top-down prediction that is not met, or is rather a bottom-up evaluation of something that is not meshing. I mean, these are I think this boils down to now some parsing, some conclusions from parsing experiments we are taking, and we see that both top-down and bottom-up models is, of course, not just agreement, but we're talking about categorical prediction or categorical integration seem to involve inference agility. So what's your take on that? If we can also go to this interface with linguistic computation and say computational linguistics and say, well, that's more of a bottom-up or a top-down, and the link to the LAN mechanisms. Okay, thank you.
So I certainly think that there's something bottom-up and something top-down. Of course, I mean, we can't deny the coexistence of these two mechanisms. So but I think that what I mean, my take on on the inferior frontal gyrus, on the frontal effects that we have, they have more to do with the top-down processing, with top-down processing. So that is my short answer to that.
Okay. And your intuition would be just a motivation, just to get better. It's because of the different contrasts you see that you have a dissociation between temporal and frontal for the different contrasts that you have been testing, or it's more convergent evidence from different.
I think it's more for the converging evidence from other. I mean, I don't think that the contrast that we used could allow us to disentangle top up, but I think it's more for the. I'm trying to see it more from the perspective of the how this fit with previous studies. Previous studies on what the left inferior frontal gyrus. Well, not so much on agreement, because there's not so much on agreement in the fMRI literature, mostly because a lot of fMRI studies are conducted in English, and English is not the best suited language to test this. I mean, you can, of course, but not to the same extent as.
Okay, and correct me if I'm wrong. So the idea of hierarchical structure in, of course, we've been very general now, but I think the model is very promising. So in the temporal lobe, the idea is rather that since you see a difference between match and mismatch, you would assume that just correct structures are basically retrievable there. So there is no need for doing an evaluation that would be done incrementally in the inferior frontal regions.
So I mean, in the temporal regions, especially in the posterior temporal regions, we see sensitivity to both correct and incorrect. So I mean, what I was trying to convey, I don't know if I made it, but so the fact that it is more sensitive to the correct instances of agreement tells you that it builds something. Then the difference between person and number tells you what. Basically, the information to which it is more sensitive. It is more sensitive. So it could be that it's sensitive to the higher or lower position of the feature in hierarchical structure. So that was a way to interpret the. So, I mean, I'm making reference to theoretical analysis. We also have data, preliminary data that we presented at SNL a few weeks ago about basically we used the same design as Payet, more or less the same design as Payet, and contrast Basque and Spanish, and we saw that both Basque and Spanish show branching. We saw branching effects in the posterior temporal gyrus. So in Spanish, you branch
left and right.
So and there was no. So that also tells us that there may be something going on about hierarchical syntactic structuring there. Okay,
nice, perfect. Thank you, Simona, for this motivated answer. We have 2 questions already from the chat. The people who post a question can also turn on the microphone and ask the questions themselves. So Joanna, if you want,
please.
Yes, to make it more interactive. So Joanna first, then we have Will and Mädchen afterwards. So Joanna, if you want, you can turn on the microphone and ask your question yourself. Otherwise, I'll read it for you. Okay, let's wait 2 more seconds. Oh, okay, prefer to not. Okay, I'll read the question for you then. Joanna makes a reference to a paper by Braga et al. 2020 or 2019, who locate the posterior middle frontal gyrus in the specialized language network in Fedorenko sense. Might this mean that both person match and mismatch are specifically linguistic?
I mean, you don't find features only in language. I mean, there are features you can use features to describe objects in, physical properties of objects, but in I think that in this case, person and number features, these are linguistic descriptions, so linguistic properties. And yeah, so this is also why we thought that we thought about this dissociation between middle frontal and inferior frontal. So the middle frontal areas are sensitive, responsive to mismatch in general, while you see some sort of dissociation in inferior frontal area. So this could somehow, it's an empirical question, of course. So, but it may hint at some more linguistic sensitivity. So the language specific sensitivity. Yes.
Okay, I hope, John, that answered the question. I would like, so we have also questions from YouTube, but I will ask maybe William. Well, if you don't mind, you can also turn on the microphone yourself and ask the question. Otherwise, I read the question for you. Thank you.
Yeah, I don't mind.
Cool.
You can hear me okay?
Sure, go ahead. Thanks, William.
Yeah, so thank you for the wonderful, coherent presentation. It was nice to see it like an integrated set of experiments, looking at this from different angles. My question was like the dynamics of processing, right? So if I was correct in interpreting what you were presenting, it was mostly subject-verb agreement in which the subject precedes the verb. And then I'm assuming that this is the case in Spanish, that's an obligatory agreement representation. So my question would be, what about cases of agreement where you can't predict the agreement relation until you get to the final element temporally? And like I'm thinking of an aphra, right? Like, Bob was tired because he stayed up all night, right? And then once you encounter the pronoun, then you have to go backwards. So just what would it look like? What would the stuff you're presenting look like?
We haven't tested it, but there are studies by, if I remember correctly, by the Cooperberg group. Studies from the 2011 or 12 years, I remember. So where they basically showed that that incongruence between a pronouns and a pronoun and its antecedent showed, for example, middle frontal gyrus activation. So this was also another. It's also other evidence that adds to the sensitivity of this strip, so to say, to feature mismatch. So that is the, and we haven't tested it, but I would assume that then if you contrast correct versus incorrect, then you would probably find something along the lines. Now, of course, the dependency would not be local as the ones that we have tested in ERPs and fMRIs. We have always resorted to a local relation. So that the impact of the long distance relation, I don't know what that would be, but yeah, I would say that I would bet that we would find similar correlates.
Yeah, the reason I ask is we did a little bit of work a long time ago looking at backward anaphora, right? So we had a distance manipulation. We manipulated the linear distance between elements, which you could do with subject-verb agreement as well, right? And the effect in Broca's area depended on the dependency orientation, right? Because like if it was a backward anaphora, then it give the prediction of the existence of the antecedents, and then you could see that there was increased activation given the distance. But your previous work didn't show. So I'm just curious how the dynamic might change.
It's interesting. We didn't test it in either in fMRI or EEG data. We had a sort of distance manipulation in an eye tracking study where we tested local subject verb agreement and local non-local adverb verb agreement. This is the 2008 experiment by Nicoletta Bionda. I presented only the person number part, but there was also the tense part, and we saw that, for example, for tense, the effect changed based on whether the adverb and verb were adjacent or not. And it was interesting to see that it was the opposite of what we would have expected. So when they are local, when they were local, the effect was appeared later on compared to when they were distant. So it was a sort of, so what we interpreted it in the sense that, the more time you have to unpack, for example, the semantic information that is contained in an adverb, the earlier and the more precise, maybe, well, not more precise, but the earlier you detect the incongruence between the adverb and verb. So that was that is the only say distance manipulation that I have worked on. But what you said about the backward and anaphora, it's that's really interesting. And
thank you.
Maybe just to add on that, that we also had Cristiano and Casey and Tolokanal. I mean, they're working a lot on eye tracking and mismatch between in cleft, for example, in cleft construction. It is the boy that teachers met yesterday compared to pronoun mismatch. Also working on person features, and at least we gained some information on the distance relationship between, so carrying over different amount of features and how those would match or mismatch with another element of the same nature that could be a full and pure pronoun. I think on eye tracking we could already see something interesting also. Which would map to pretty almost transparent hypothesis from linguistic theory.
It's what we
make some granularity of the DP a little bit more clear.
Yeah, it's something that the work that we did with Bojana Ristic that went along those lines. So to see what happens when you are in the process of establishing a relation. So a dependency, you don't know. I mean, you don't know when, you don't know at which point, but let's see what happens in the meanwhile. Yeah, and eye tracking for that is an ecologic. I mean, it's very well suited because you don't even need an auxiliary, to say, task. So you just measure the just comprehension questions. So it's very ecological in that sense.
Okay, thanks, Simona. I think we have questions from YouTube. William, are we fine with this? Okay, great. Thank you, Simona. We have 3 questions from YouTube. I need to read that myself because and to speak them up because of non-interacting possibilities. From Christina Teichert, if I pronounce it correctly, and she asked 3 questions. I will read that all 3 together. Maybe I'll help you with a short-term memory in case we have problems. So the first was, which age group were the participants in the experiments? Okay, so age groups?
The classical college student group, 18 to 35. 40 sometimes, depending on, but the classical college. Okay,
second question was, did persons with language impairment also take part in the eye tracking experiment?
No, they were only, they were neurologically unimpaired, and they had no attention, no reading disabilities, so they were college students. Just
healthy. Okay, and the last one, I think it goes back to what our first question from the audience was, in how far can agreement be processed in the non-linguistic domain?
That's exactly what we would like to know. We're setting up this experiment where we want to see how. We want to see how, if you can find agreement relations in a non-linguistic domain, basically. So, as I said, in the outside of language, you have features and you build, representations or recognize objects based on matching features. Features that match or mismatch with your. So in theory, there could be, but we don't know. So we want to see how whether this is really the case.
Maybe just a link to this answer. I very much like in a way you stole a possible question when you wrote at the end primitives, and that's very important because it comes back to the question. Okay, what is really, I wouldn't say syntactic specific, or really a language / agreement specific, and what it's not. So number, you find number in semantics, for example, informal semantics and implication numerosity, cardinality. You said that very clearly. Person. Can we talk about the gradient, or can we talk about linguistic and semi-linguistic agreement? So I think this is an absolute pertinent questions, and I think that would help us also looking better at these distinctions you have been posing across the different types of agreements. So I very much like the idea of talking about primitives and splitting into features, not nanosyntax, but do you have a feeling that there is, that you have really, we don't want to go to the north to talk about that, but does it make sense for you to talk about linguistic specific form of agreements that are needed also from an evolutionary point of view to communicate, and some that might be cross domain? Because I think this question has been asked by two people, and I think it's very important what you're doing. So testing forms of agreement outside of language and ways to think about how something can agree, how two things could agree outside of language domains.
To be honest, I hadn't thought about the evolutionary side of that, but now that you mention it, it could probably. I mean, I don't think it would be the smoking gun to can I say? I mean, but it could provide indirect. If we found evidence for agreement outside of language, then that could have evolutionary. It could be read, I think, it could be given some evolutionary value to this. So, as I said, in principle, you have agreement outside of. I mean, you can have agreement outside of language. So you match objects based on their physical properties, and you create scenes. I'm not an expert on visual perception, so I'm just this is my naive take on this, but it's something that, to my knowledge, it hasn't been tested. So,
okay. So as a concluding thought, now that also William is there and Simona, maybe a question for both of you, but in a very cozy manner. So what do you see? We have been asking these questions to all our tandems. So what do you see the challenge? What kind of challenges do you see about neuroscience of language in the next 5 years? So what would you like to answer according to your opinion about science and language, or where to sit probably theory in all this discussion? I know it's a huge question, and it would be nice to say, please just use one answer. But where do you see yourself in the next 5 years in terms of what would you like to reach? So is there a place for, we need to go back to theory. We need to embark in common definitions and norms, as many people were saying.
I think we need theory. I mean, the thing is, we should find some cross. We should probably improve the crosstalk between theory and experimental stuff. I mean, not that there is crosstalk, and I presented data that I've interpreted theoretically, but there are some aspects that maybe, so like, I don't know, it's something that I discussed in a paper of mine. So the competence versus performance distinction. So that's something that, I think that grammar is processing. So I know that, so that for me shows that there's some crosstalk to be done yet, to find common grounds. And and even what I said about the features. So it's easy to think of features when you in theory, but then when you experimentally test language processing, then is it do we want to provide maps of feature representation? I don't know. So this is something that we should. So it's something at the interface, as I said. So there should be more communication in between theory and practice, so to say. I don't know what William thinks about it.
I agree. And I think, what you were presenting today highlights some of the issues, like we like to use certain constructions to probe things like agreement mismatches, right? But the problem I think we have is we need a good performance model that implements these grammatical things. And we need performance models, not just for grammatical expressions, but also to handle these cases where things are ungrammatical or deviate from acceptability or unusual in certain ways. And that, is not the sort of goal of theoretical linguistics to provide that. So that has to be provided in some way, right? And, there are different approaches to that. As you mentioned, one is like the more direct implementation, but there are others, and not just for, again, those particular constructions, but in the cases when things go wrong or need to take into account other factors that affect online processing. I don't know if I mentioned this yesterday, but I think I was chatting with Emiliano. I was at CUNY in 2012, and Johnson gave the keynote lecture, and he was like, "Oh yeah, don't do processing. Like, what are you doing? This is too hard," right? And I took his call. I tried to interpret them in a way that was more like, it's really hard, right? And you have to put a lot of work into developing the linking theory between the linguistic theory and your behavioral experiments, and then doubly so with your neuroimaging experiments. So I think that it just needs to be done. And I think it is being done to a certain extent, right? And you find these interesting constructions, right, which allow you to, alleviate some of those problems by looking at those partial, the unagreement constructions, right, were interesting, right? Perfectly acceptable, but allow you to look at something that you previously looked at with an ungrammatical utterance. So I think that's also really helpful, is like searching for those situations that minimize that complexity.
Great. Yeah, and it's also interesting that Simona is saying grammar is processing, and William was asking yesterday what happens when you remove grammar from performance, which boils down to the same.
Right.
The exact same point, and that we could be more happier than seeing this convergence between our keynote speakers. So our intuitions were pretty fine on that point.
One thing I wanted to add is Jixing and John Hale's work, right? Like, if you develop detailed computational models, then that can be really helpful, right? Because then you can model a whole complex set of processes that you expect to be ongoing. And so I think that work is really great and really pushing the things forward. You can implement agreement, into this. I'm not as familiar with their work in detail, but I'm assuming that they looked at agreement, or they have to some extent implemented that, right? But you could do what they do, right? And assess the effect, just for agreement implicitly without having to look at a deviant construction.
That's a potential line of something that can be pursued, and for sure
in the future.